to the video lecture for section R.8. This is college algebra, and my name is Jorge Abiyang. So the objectives for this section, we're going to work with nth roots, simplify radicals, rationalize denominators, and then simplify expressions with rational exponents. So the first thing is we're going to work with nth roots. So the principal nth root of a real number a, as long as n is greater than or equal to 2 in integer, symbolized by, you can hear the nth root of a is defined as follows. So the nth root of a is equal to b means that a is equal to b raised to the n power, where a is greater than or equal to 0, b is greater than or equal to 0, n is an even number, a and b are real numbers if n is odd. And that's important. If n is odd, then a and b can be any real number. As long as n is even, then a and b have to be either 0 or greater. So for the first example here, a, we have the cube root of 8. Cube root of 8 is equal to 2 to the third power. So what happens is we can cancel out the 3's. So the third root and the third power, and then we just simply end up with 2. For b, we have the cube root of negative 64, which becomes the cube root of negative 4 to the third power, which is just equal to negative 4. For c, we have that we have the fourth root of 1 over 16, which becomes the fourth root of 1/2 to the fourth power, which is simply 1/2. And then for d, we have the sixth root of negative 2 to the sixth power, which is equal to the absolute value of negative 2, which is equal to 2. So just be careful with this one here, because this is not necessarily no solution or undefined, if you will. So in general, if n is greater than or equal to 2 is an integer and a is a real number, then we have that the nth root of a to the n power is equal to a if n is greater than or equal to 3 is odd. And then we have the nth root of a to the n is the absolute value of a if n is greater than or equal to 2 is even. So now we're going to simplify radicals. So here's some properties. So the nth root of a times b is equal to the nth root of a times the nth root of b. The nth root of a over b is equal to the nth root of a divided by the nth root of b, as long as b does not equal 0. And then the nth root of a to the n power is equal to the nth root of a raised to the n power. So here we have for a the square root of 32. And so what we're going to do is we're going to find a perfect square that divides 32, which just happens to be 16. 16 is a perfect square. So then square root of 32 becomes square root of 16 times the square root of 2. We can separate that, one of the rules that we saw previously. And then that becomes 4 square roots of 2. For b, we have the cube root of 16. We're going to find a perfect cube. So 8 is a perfect cube. So it becomes a cube root of 8 times the cube root of 2. And then, of course, the cube root of 8 is equal to the cube root of 2 to the third power, which is 2 times the cube root of 2. And then for c, we have the cube root of negative 16x to the fourth. And so we can separate a negative 2 and a 2, separate an x to the third and an x. So when we do this, we have variables. What we're looking for is to have the same, if this value is greater than the index, we can actually separate them, and then we know that the cube root of x to the third, we can cancel that out, or we can take the x out, if you will. So we end up with the cube root of negative 8x to the third times 2x. We can go ahead and separate out the cube root of negative 2x to the third, which is what we had, the negative 8x to the third over here. And then so we're going to end up here with just negative 2x outside times cube root of 2x. And then for d, we have the fourth root of 16x to the fifth over 81. So we're going to find out to see if we can simplify these into the fourth power. And so we have 2 to the fourth, x to the fourth, and x. So remember, these two together become actually gave us the x to the fifth. So we can cancel out the 4's, if you will. And so we end up with the absolute value of 2x over 3 times the fourth root of x. And then combining like radicals. So if in order for us to add these together, we have to have the same radical. And in other words, we have to somehow end up with the square root of the same value. So 12 is 4 times 3, where 4 is a perfect square. So we can separate 4 times 3, so we end up with negative 8 times square root of 4 times square root of 3. Square root of 4 is 2. So then that becomes negative 16 square roots of 3 plus square root of 3, which then equals negative 15 square roots of 3. For this one here, so we're going to go ahead and work with each one individually. So the first one ends up being the cube root of 2 to the third x to the third and x. This second one becomes a cube root of negative 1 times x. The third one, 4 times a cube root of 27x, becomes 4 times a cube root of 3 to the third x. And then you can see here, follow along, how we slowly start simplifying them. And then ultimately we end up with 2x plus 11 times the cube root of x. The next thing is rationalize denominators. So here are some rules that we can use to rationalize denominators. So if it's the square root of 3, you multiply by the square root of 3. If it's the square root of 3 plus 1, you multiply by the square root of 3 minus 1. And this is a conjugate. Square root of 2 minus 3, so it's square root of 2 plus 3. And you can see the different ones. Now, this one, cube root of 4, and you're going to multiply by the cube root of 2. And the reason being is because 4 times 2 gives us 8, and 8 is a perfect cube. So if it's square root, we really just multiply by itself or the conjugate. But when you get another root, an nth root, what we're trying to do is find either a perfect cube or a perfect fourth power, and so on and so on. So here we have these three examples. So for the first one, we're going to multiply by the square root of 3, the numerator and the denominator. The square root of 3 times square root of 3 actually becomes square root of 3 to the second power, which is simply 3. So then it becomes square root of 3 over 3. For the second one, we have 5 over 4 times square root of 2. So we're going to multiply by the square root of 2, numerator and denominator. Our numerator becomes 5 square roots of 2. Our denominator becomes 4 times square root of 2 to the second power, which is 4 times 2. And then finally, the final answer is 5 square root of 2 over 8. Now, for C, we're going to go ahead and multiply by the conjugate. You can see the conjugate is square root of 3 plus 3 square roots of 2. So what happens when you multiply by the conjugate is that you end up with a square of the first value minus the square of the second value. And then, of course, those they should become real numbers. And so ultimately, we end up with the square root of 3 squared is 3. And the square root of, and then 3 square roots of 2 squared ends up being 18. And then you can see that we finally end up with 6 plus square root of 6 over 15. The next one, we're going to simplify expressions with rational exponents. So if a is a real number and a is greater than or equal to 2 is an integer, then a raised to the 1 over n is the nth root of a, provided that the nth root of a exists. So 4 raised to the 1/2 is equal to the square root of 4. 8 raised to the 1/2 is equal to the square root of 8. Negative 27 raised to the 1/3 is the cube root of negative 27. And of course, 16 raised to the 1/3 is equal to the cube root of 16. So the next thing, if a is a real number and m and n are integers containing no common factors with n is greater than or equal to 2, then a raised to the mn is equal to the nth root of a to the m, or the nth root of a raised to the m power, provided that the nth root of a exists. So 4 raised to the 3/2 is actually equal to the square root of 4 to the third power. Negative 8 raised to the 4/3 is actually equal to the cube root of negative 8 to the fourth power. 32 raised to the negative 2/5 is equal to the fifth root of 32 raised to the negative second power. And then, of course, we have to get rid of the negative exponents. And then d, 25 raised to the 6/4, we can reduce that. And then that becomes the square root of 25 to the third power. And, of course, each of these we simplified to a real number. So the next one, we're going to simplify expressions containing rational exponents. So here's a, b, and c. So for a, we're simply going to multiply. So we have x to the raised to the 2/3 times x. Well, here we have to give out the 1/2 first, which is what they did here. And then we end up with, once we multiply these out, we end up with x to the 2/3 times y times x to the negative 1/2 times y to the 1/2. And so that really should have been parentheses there, so I apologize for that. And so now we combine like terms since we're multiplying. And so we end up with this group here and this group here. When we're multiplying the same base, we just add the exponents, which is what we did in this step. And then, of course, since the x is raised to the negative 1/3, that becomes our denominator. In this one, we give out, actually, we don't give out the negative 3, but we can actually find the reciprocal of this fraction, and our exponent becomes positive. So you can see what they did from this step to this step. And then here, you distribute the 3, and then, of course, simplify as much as you can. And the same thing here. In this case here, what they did was they took the x to the 1/3, brought it up here. They took the y to the 1/3 and brought it down to the denominator. This is kind of a convoluted way of doing it. So when they did that, they just added all the exponents, gave out the 1/2, and then simplified. There's actually a better way of doing this, and I'll show that in class. So example 10, factor an expression containing rational exponents. So we're going to factor and simplify the following. And so begin by writing 2x to the 4/3 as a fraction with 3 in the denominator. And so you can see here how we end up writing that. And then so this term right here becomes this term. And then we can go ahead and take care of this term over here. So you can see that that becomes the 6x to the 4/3 over 3. In order for us to combine these two, so the 2 we multiply by 3. And then we have our numerator. We can simplify our numerator a little bit more, and then ultimately we end up with 2 times x to the 1/3 times 7x plus 2 divided by 3. And that's the end of R8. Thank you.